Okay, so we had our two functions, f of x and g of x. Okay, so for the first example, we were plugging our g of x function into f of x. Okay, so again, you're taking this term, the square root of 9 minus x squared, and you're plugging it into this x here. All right, so what we did was we plugged that in, and then we still have the squared minus 9. That's still part of your f of x function. Okay, so the first thing we did was we just substituted in 9 minus x squared, the square root of 9 minus x squared, into this part. Okay, so putting this into here doesn't mean that we get rid of the rest of f of x. Okay, we still have, or we had the squared and the minus 9. In this particular case, the squared and the square root eliminate each other because they're inverse operations, right? And then we ended up subtracting the 9s, which eliminate each other as well. Okay, but that doesn't always happen. Again, for the second one, you're taking x squared minus 9, and that's going into the spot of the x here. Okay, so when I plug it in, I still need the square root, because I'm talking about g as my parent function. So I need the square root of 9 minus, right? And here is what I plugged in to the x squared minus 9. That replaced that x. So I still have the squared, and I still have the 9 minus before that. Okay. Let's do one more example like this, and then we'll move on to what we're doing today. Maybe I'll do it a simpler version. All right, let me see if they have an example here, so I'm not just making up. Okay, so we got some somewhat simpler functions, right? This is only a linear. Here we have a squared, so we'll have to deal with that eventually. So the first thing I want to do is find f of g of x. Okay, so again, what I'm going to do is I'm going to keep the f on the outside. What does g of x equal? I'm going to substitute it in here. So I have x squared minus 16. Okay, so again, all I did first was I replaced what g of x was in here. So again, this is telling me that in my f function, I'm replacing any of my x values, right, my variable, with the expression x squared minus 16. So I have the 3, right, because I'm talking about the f. So I have 3. Now, instead of x, I'm going to write what's in the parentheses, right? That's how we normally do functions, right? And I can't forget that f still has this plus 1. My f function says I'm taking my input, I'm multiplying that input by 3, and then I add 1. So you have to make sure every part is in there. Okay, so you have the 3x squared minus 16 plus 1. Once you've substituted in, right, you don't see any more function notation, there's no more f or g, then you can do anything you need to simplify. All right, so our first step here would be to distribute the 3. So you're going to have 3x squared minus 16 times 3, 48. And then we still have this plus 1. We combine any like terms, right? The 3x squared is by itself. Negative 48 plus 1 is negative 47. Okay, so we're plugging that in. Once we start dealing with numbers, it might be a little easier because you don't have to worry about, distributing and simplifying and all that. All right, let's take a look at the reverse. Okay, g of f of x. So again, I'm going to keep the g on the outside because that's the last thing I'm doing. Okay, my f of x is 3x plus 1. So anywhere in g, I'm substituting 3x plus 1 in for the x. So this is telling me my x, which is now 3x plus 1. I'm squaring that, right? That's what my g function is telling me I'm doing. And then from that, I'm subtracting 16. Okay, so again, I took this 3x plus 1, and I plugged it in for the x into g, and then I still have the rest of my g function, the squared minus 16. Okay, squared minus 16. Anything around this x still needs to be there, right? This step was just substituting in this term into your x. So here, again, be careful, you have to FOIL 3x plus 1 times 3x plus 1. Okay, that's going to get us 9x squared. Then we have a 3x and a 3x, so that's going to get us 6x. 1 times 1 is plus 1 minus 16. Right, and then we just combine like terms, 9x squared plus 6x minus 15. Now this we can actually reduce if we'd like to. Okay, a common factor between all three of these terms is 3. I could take a 3 out of everything. So you could take it a step further. You can pull that 3 out, and then we're left with 3x squared plus 2x minus 5. All right, but if you gave me this as an answer, you'd be right. I wouldn't mark you wrong. Let's take a look at one more, just because I talked about it yesterday. Okay, so you can plug a function into itself. Okay, I can use the same function twice. So my steps are still the same, right? The first thing I'm going to do is I'm going to replace the inside with what f of x is, 3x plus 1. So now, it's like Inception. I'm taking this 3x plus 1 and I'm plugging it back into the 3x plus 1. So I have the 3, right? That's the first thing I start with for my f function, the 3. I'm replacing x with what's in the parentheses. And then I finish off the function plus 1. Okay, so here it's just one quick distribute 9x plus 3 plus 1 to get 9x plus 4. Nothing to simplify there. That's our final answer. All right, any questions there?
No, it's actually better now. Thank you.
Okay, good. I'm glad. You're welcome. All right, so let's talk about evaluating, because evaluating is actually, I think, a little easier. Okay, so evaluating composite functions, I like to think of it as like a chain reaction. Okay, so let's come up. Actually, let's use the f and x, the f and g we had before. What was g of x? X squared minus 16. Okay, so now I have my f of x is 3x plus 1, g of x is x squared minus 16. I want to find f of g of 1. Okay, so like I said, this is going to be a chain reaction. The first thing I'm going to do is inside the parentheses, right? That's our order of operation, PEMDAS. Inside parentheses goes first. So the first thing I'm going to calculate is g of 1. Okay, so that one's simple. I take 1 and I plug it into my g function. I'm going to have 1 squared minus 16. 1 minus 16 is negative 15. This is my answer for g of 1. I go back and I substitute g of 1 for its value. So now this is telling me I'm looking at f of negative 15. Okay, so my output for this becomes my input for this. All right, and that's where the chain reaction happens. Right, you get the answer for this, but you're not done. This answer is now this input. So you take the negative 15, you plug it into there. 3 times negative 15 plus 1. That's going to get us negative 45 plus 1. Our final answer is negative 44. Okay. Actually, I have a kind of cool visual for us here. I'm going to change the function, our second function, though. Okay. So here, okay, my first function, I stayed 3x plus 1. But now I made my second function x squared minus 2, because if I had x squared minus 16, I wouldn't be able to see it on this graph, right? It would be like really, really far down. Okay, so somebody pick an x value. Give me any number for x.
9.
9. Wait, is this the right one? Yeah, that's the right one. Maybe a smaller number.
3.
3, okay. Wait a second. This isn't what I had before. Give me a second. Sorry, guys. Nope, this isn't the one. What happened? Okay, so let's do it one more time. So we had 3x plus 1. Yeah, plus 1 x squared minus 2. No, 2. Okay, so there we go. So our x was, we said, 3. So for 3, right, I would plug in 3 to here. So 3 times 3 is 9, plus 1 is 10, right? So we would do that. Oh, I'm sorry. Wait, what? I'm sorry. We would plug it into g of x first, right? G is their inside function. G is our inside function. We plug in this. We get 9 minus 2, which is 7. Okay, so here, right, we look at this graph. That's 7. So now I take that 7, and that's my new x value. And then I go all the way up. 3 times 7 plus 1 would get us 22. All right. Okay, so let's do it with a smaller number maybe. Let's do 0. X is 0. Okay, so when I plug in 0 to my g of x, I go down to my g of x function, and it gets us negative 2. So now that negative 2 is what I plug in. That's my new x value. When I plug in negative 2 to my f, I get negative 5 as an answer. All right. Maybe what I'll do is I'll give this to you guys. It might pop up as an assignment, but it won't be an actual assignment. You guys can play around with this. All right. Let me see if there's what else. We still got 5 minutes. No. Okay. How do you feel about this topic? You know, with our with evaluating with numbers. Do you want to go over one more example, or do you feel comfortable?
It's good.
Oh, wait. Actually, can you do one more example?
Okay, yeah, we got time. Let's do one more. Okay, so we got two functions here. Oh, let me get rid of that red line. F of x is 2x plus 5. G of x is 4x squared plus 1. So actually we'll do f of g of 0. And then let's do it the other way, g of f of 0. Okay, so this one here, okay, remember our inside part, we do that first. So we calculate g of 0. Plugging in 0 there, 4 times 0 squared plus 1. Well, this is easy. That goes away, and we have 1. So g of 0 is equal to 1. So we go back to our original. I substitute g of 0 with 1 because that's its value. And now I'm plugging in 1 to my f function. So you have 2 times 1 plus 5. Okay, so our answer is 7. Okay, so do you think, I'll ask you guys, do you think this is going to be the same thing? Are we going to get 7, or do you think we're going to get something different?
We're gonna get the same.
All right, so let's see. So now I'm plugging in 0 to f. Okay, remember the inside tells you what you work with first. So f of 0, 2 times 0 plus 5. All right, again, this doesn't matter because I have a 0, so I have 5. So this 5 replaces the f of 0. G of 5, 4 times 5 squared plus 1. Well, it looks like we're going to be a little bigger than 7. We get 25. 25 times 4 is 100. 100 plus 1 is 101. Okay, so very different answers. Once in a while, you might end up with the same answer, okay? But usually that's kind of just like a coincidence, okay? It's not, don't rely on them being the same answer, okay? Just like if I kept this as an x, right? F of g of x would give me something different than g of f of x, right? And we saw that over here, right? Here, f of g of x was, where'd it go? 3x squared minus 47. Here, g of f of x was this trinomial, 3 terms. Okay. All right. So I'm a little torn on what to do because I usually don't like giving homework over the weekend, but we have a 3-day weekend.
It doesn't have to be mandatory.
No, so I won't do it. But Tuesday we're gonna practice this a lot, okay? And then we'll see how we do Tuesday. Okay, so nothing over this weekend. You guys are lucky. I'm feeling good, and also I got stuff to do. So, all right. So, any questions? All right, the only other thing that we might be doing with composite functions is identifying what they are, okay? But I don't think we're going to spend too much time on that. I got to take a look to see if we're doing the final this year, how that's going to look. All right, so if you guys don't have any other questions, then that's all I got for you today. Enjoy your extra day off on Monday, and I'll see everybody on Tuesday.
Thank you, you too.
Bye.
Have a nice day, guys.
You too.